Hello everyone, and welcome to this webinar on how to leverage mainframe data with Hadoop. I'm Jorge Lopez, Director of Product Marketing for SyncSort, and I'm very happy to be sharing this virtual stage with my colleagues. We have Matt Brandwine, Director of Product Marketing for Cloudera, and we also have with me Steve Topman, Director of Strategy at SyncSort. Before we begin, I just want to let you know all lines are muted, so we ask you to please use the Q&A feature at the bottom right corner of your screen. We encourage everyone to submit any questions you may have during the presentation, and we will try to address all of those at the end. And we hope this is going to be a very interactive presentation. Hopefully it feels more of a conversation. So these are the things that we have prepared for you today. First, we look at the importance of mainframes and the role they play today, including some of the challenges and opportunities to augment these systems with Hadoop. Then I will show you how SyncSort and Cloudera can help you close the technical, skills, and costs gaps with our joint solution. We will follow with a demonstration, and finally we will touch on some of additional considerations before we close with a real case study. So the first thing we all need to recognize is that mainframes today play a very important role in many organizations. Top telcos, retailers, insurance, healthcare, and financial organizations of the world still rely on mainframes for their most critical applications. When talking to these organizations, it's not unusual to hear that up to 80% of their corporate data still comes from the mainframe. Now, that is some serious big data, and organizations know that they cannot afford to neglect it. But the question is, can you afford to analyze it? Well, mainframes today costs an average of $16 million a year for the typical $10 billion organization. And that is why many of these organizations are now looking at Hadoop and making mainframes a core piece of the... Just imagine for a second the kind of insights that you could get by combining detailed transactional data from mainframes with clickstream data, web logs, and sentiment analysis, for example. But to understand the challenges, we first need to understand how mainframes work. Mainframes provide extreme performance and reliability, and that's why they command a high premium. So you end up with expensive processing and expensive storage. If you are familiar with mainframes, you know that you pay based on CPU utilization. That means the more processing you do on the mainframe, the more you pay. But this also means that any reduction in CPU time translates into instant savings. Now, when we talk about storage, mainframe storage costs can reach upwards of $100,000 per terabyte. In many cases, a lot of this data is still backed up to tape. In the end, all of this means that the large majority of the mainframe data today goes untapped. And Hadoop is offering for the first time a realistic approach to tap into all this data, an approach that is economically feasible while providing the required levels of massive scalability. So offloading mainframe data and processing into Hadoop is not trivial, and without the right tools, you may end up stalling your big data initiatives. So the way I like to talk about this is in terms of 4 dimensions, which obviously makes it a little bit difficult to present in a 2-dimensional screen, but I'll try to do that. And the first thing we have is the integration gaps. Hadoop has certainly become the operating system for big data, and while it offers a set of tools and very scalable services to process the most demanding data volumes, it doesn't offer native support for mainframes. So you are on your own when it comes to mainframe connectivity, data translation, understanding COBOL copybooks, etc. Second, we have a skills gap. both mainframe and Hadoop skills are in very high demand and difficult to find. You can now imagine what it takes to find developers who understand both technologies. Just to put things into perspective, COBOL programming appeared in the late 50s, while Hadoop in 2004-2005. That's over 40 years of difference. Then we have security. Mainframe manages some of the most sensitive data in the enterprise. If you cannot guarantee the secure access, processing, and distribution of data, your initiative won't get very far. And finally, there's obviously the cost factor. To understand this, any additional processing on the mainframe to sort, filter, copy, or download the data costs CPU cycles, which directly translate into additional costs. And that's not the end of the story. There's also a huge cultural gap between these two groups, mainframe and Hadoop. They have different ways of approaching problems. They have different concerns, interests. For instance, typically for mainframe developers, quality, accuracy, reliability, and security are on top of everything else. While for Hadoop developers, immediate use or availability is more important. I guess if you miss a Twitter feed, it's not a big deal, but missing a financial transaction can really get you into jail. And to explain this, my colleague Steve likes to borrow a slide from Gartner Research, who I think explains very well the kind of differences we see in the mainframe world. But then we thought, how can we explain our solution using the same slide? And that's when the shirts came into the picture. And by the way, everyone attending this webinar will get a chance to pick the right shirt. So with over 40 years of our growing contributions to the Hadoop community, we can help you close these gaps between mainframe and Hadoop. But I guess this is a much better picture to explain the story. Together with our partner Cloudera, Simsor combines decades of mainframe expertise with state-of-the-art Hadoop capabilities to provide a painless and seamless approach to exploit all your data in Hadoop, including mainframe. Our joint solution can help you close all the functional, skills, and cost gaps so that you can ingest, process, and securely distribute your mainframe data with Hadoop. Over the rest of this presentation, you will see how our approach can help you achieve direct connectivity to mainframe without installing any additional software on it, and this basically means zero MIPS. Also achieve on-the-fly data translation from common mainframe data types such as FCDIC, packdecimal to ASCII, plus leading support for complex COBOL copybooks. We provide support for uploading data and batch processing from mainframe into Hadoop, and of course, all the scalability that Hadoop is known for. Now, all of this is tightly integrated with Cloudera and runs as an integral part of your Hadoop cluster. So let's start by looking at the platform for big data, and for that, I'll pass the presentation over to Matt. So, Matt?
Thank you, Jorge. Good to meet everyone. So my name is Matt Brandwein, Director of Product Marketing for Cloudera, and we thought it would be good to maybe start with a bit of an overview of what Hadoop is, since it may be a new concept for many. So Hadoop is an open source platform for scalable, fault-tolerant storage and processing that runs on a cluster of industry-standard servers. At its core are two components. There's a distributed file system called HDFS and a framework for distributed batch computing called MapReduce. Hadoop is really a flexible, scalable, and very affordable platform for data management. So whether it's used to deliver innovative solutions that detect fraud, deliver more targeted products and services to customers or find criminals, or to optimize existing infrastructure, to deliver an active archive or a data hub, as some have called it, or to offload data processing from a mainframe or data warehouse. Hadoop is really changing how organizations view their data. But it turns out that to deliver these benefits, you need just more than these two core components, just a file system and a batch processing framework. You need some way to get data in and out of the system. You need ways to gather, log, and event data. You need workflow tools, and you need security and metadata management. And above all, you need to ensure that all of these components work together and with your existing infrastructure, and that your team is trained and prepared to use the new system. And that's where Cloudera comes in. So founded in 2008, Cloudera was the first and is today the leading provider of open source data management powered by Apache Hadoop at the core, and the leading contributor to the open source Hadoop community. Cloudera really provides everything you need to be successful with Hadoop in the enterprise, including software, education, and professional services. At that core, we provide an open source distribution, just like Linux is a distribution, of Hadoop called CDH, that is the most advanced, complete, stable, and widely deployed on the market. Chances are, if you're trying to find folks on job boards that have training in Hadoop, they're trained on CDH. Now remember, Hadoop is about giving you a flexible, scalable, low-cost way to store all your data in a variety of ways to use that data in one system. Because once you're storing that much data, it's really no longer economically or logistically practical to move it again for each new kind of workload. So beyond just batch MapReduce, Cloudera also provides additional open source frameworks for more and different ways of getting value from your data. In particular, we provide some additional query frameworks that are native to Hadoop. So some of you may have heard of Cloudera Impala, which is a massively parallel, or MPP, SQL query engine natively on Hadoop, which enables you to use your existing BI tools with your data in place in Hadoop. We also provide a search platform called Cloudera Search that provides near real-time indexing and faceted search for new kinds of data, unstructured data that doesn't lend itself to a BI experience, or also lends itself to new populations of users that may not be familiar with Hadoop or BI, but they know how to search. Our commercial offering, Cloudera Enterprise, couples that open source platform with support and a suite of system and data management software that really makes Hadoop enterprise ready. We also offer comprehensive consulting services and the broadest array of Hadoop training and certification programs to ensure that you can bridge that skills gap from the Hadoop side, from the Hoodie side. In addition to SyncSort, we've partnered with over 700 organizations across hardware, software, and services to help meet your big data goals. And really the proof of success for us is customer success. So leading companies in every industry run Cloudera in production, including over 65% of the Fortune 500 in finance, telecommunications, retail, internet, insurance, energy, healthcare, biopharmaceuticals, networking, and media, plus all three of the largest U.S. intelligence agencies and two of the top three defense agencies. So really seeing broad adoption of Hadoop in the enterprise over the past few years. And ultimately, customers choose Cloudera for their strategic Hadoop projects because we deliver success with Hadoop and big data. The platform is not just the most complete, stable, and widely deployed, but it's really important to understand that not all Hadoop is created equal. Only Cloudera provides that interactive SQL and search capability, native high availability, and disaster recovery for mission-critical data, comprehensive security, and more. But beyond just the software, it's about delivering success through the commercial relationship we have with our customers. So in particular, we can talk about assurance, which is how we remove the risk from working with open source, novel software that may seem risky and scary. But by providing an employee base on our end that works for you, we have folks that work on all of the open source projects, and through that can provide comprehensive support across the distribution and really ensure that you have the guidance you need to understand the new technology and be successful with it. Because we've helped customers across a variety of industries, we can help you figure out how to maximize value from your investment. One of the main risk areas for Hadoop is folks that just download and deploy it without a sense of goals or objectives. But we can help you define success metrics and figure out what you really need to develop this new standard for data management. And then finally, because Hadoop is a community project, because of the number of folks we have working for you on open source, you really get to participate in the future of Hadoop. So really, we're here to work for you. And with that, I'll turn it back over to Jorge.
Thank you, Matt. So by now, some of you may be wondering, especially those not familiar with the mainframe, who is SyncSort? The answer is we are a leading big data company dedicated to help our customers to collect, to process, and to distribute extreme data volumes. We provide the fastest sort technology and the fastest ETL engine in the market. And most recently, we released the first truly integrated approach to extract, transform, and load data with Hadoop. Now, if you have a mainframe in your organizations, then you probably know SyncSort, because we run on nearly 50% of the world's mainframes, and we are the most trusted third-party software for mainframes. Our customers are companies who deal with some of the largest and most sophisticated data volumes, and that's exactly the reason they've come to us, because basically we solve data problems that no one else can. Now, these companies, especially organizations who have a mainframe, are looking into Hadoop as means to process more data with less resources and in less time. And that's how Hadoop came into the picture. So when we and our customers started to look at Hadoop many years ago, we realized there are some common denominators between Hadoop and mainframe. First, both provide a highly distributed framework to process massive batch workloads with unparalleled scalability. And most importantly, both frameworks are highly dependent on sort. And in the case of mainframes, up to 80% of all batch processing involves sort. Similarly, in Hadoop, the map and reduce phases both involve sorting data. So given our expertise on this domain, we developed a series of contributions to the open source community focused on improving performance and efficiency of batch processing through sort. More specifically, our contribution implements a new feature that allows external implementations of the sort phase in the Hadoop map reduce framework. This is not only kind of open the doors for faster and more efficient processing, but also enable more sophisticated manipulation of data within this framework. And by the way, this contribution is shipping on CDH 4.2 and later. And CDH is obviously the Cloudera distribution. Now, our contribution also enables us to seamlessly plug DMXH ETL directly into the MapReduce framework. And this is what delivers this fully integrated approach to Hadoop ETL. So what is DMXH ETL? It's a high-performance software that runs as part of your Hadoop cluster, making it easier to read, to process, and to distribute data with Hadoop. DMXH ETL basically turns your Hadoop cluster into a more robust and feature-rich ETL solution for all your data, and that includes the mainframe. Among the things that are included with DMXH is a Windows-based graphical development environment. This provides comprehensive connectivity and data transformations out of the box. So that means you can design complex data flows without ever writing a single line of code. And as I mentioned before, we provide leading support for mainframe record formats, data transformation capabilities, and file-based metadata capabilities, including support for COBOL copybooks. So now I would like to turn it over to my colleague Steve Topman, who will show you a little bit more how everything fits together, including a demonstration.
So hi everyone. Just to add another accent to the mix, my name's Steve Topman. I'm actually a Brit underneath the American twang I seem to have picked up. So I actually started my career doing COBOL code up on the mainframe to do ETL. So I guess according to Merv Adrian at Gartner, I'd be both a suit and a hoodie because now I'm doing all this stuff with Hadoop. On a side note, Matt, Jorge, and I have a little side bet about which T-shirt will be most popular. So I actually like to point out that the T-Rex is definitely the best T-shirt to go for. So you'll get a chance to choose one at the end. So there's always been this perception that the way you get the data off the mainframe is you pick up the red phone, you tell the mainframe guys exactly what data you want, and a few minutes later, it gets FTP'd over and you load it into your downstream systems. However, the reality is very different. There are numerous complicated technical steps for getting data off the mainframe, and because it's such a trusted and locked down source, there are additional processes that have to be gone through. Things like SMS compression, filtering and reformatting, data conversion, etc. But the key issue here is that every time you change the data you want, you have to go through all those steps again. So it's both costly and time-consuming. Now, the interesting thing about mainframes is when they began, storage from the beginning was very limited and expensive. So what happened was some very smart people came up with some sophisticated formats to store data and save space, things like EBCDIC, packed decimal, comp and multi-format records. Now, this is great. So, for example, with packed decimals, you can store your numerics and save half the space. The problem is when you move that data off the mainframe, you have to be able to translate it, and it's not viewable. So you have to convert these things into formats that things like Hadoop can absorb. In addition, on the mainframe, the metadata and the data are actually stored separately. Metadata is stored in these scary things called COBOL copybooks, which are always stored separately, and you can actually lose them. So you've got to be able to sync up both the data and metadata and then do the translation. So SyncSort has over 40 years of experience moving data from mainframes to open systems, so Windows, Unix, Linux, etc. And the product has automated capabilities to handle all the data conversions for interpreting the COBOL copybooks, for example, and they really make it transparent to the end user. So you can remove both the risk and cost from data discovery and conversion from the mainframe. Now, using SyncSort and Cloudera together, you can benefit from those decades of mainframe experience integrated with the state-of-the-art Hadoop capabilities, and this provides a really painless and seamless approach. SyncSort allows you to connect directly to the mainframe, and even though our software is already running on 50% of the mainframes out there, so chances are you're already running it internally, unlike other vendors, we don't actually require any software to be installed on the mainframe. We fully automate all the data parsing, transformations, with no coding required. That's no Java, no Pig, no COBOL, etc. And then we can load directly into HDFS and many other relational targets and appliances. So now Nikhil Kumar, who's our Big Data Technical Product Manager, is going to deliver a brief demo of a real-life customer. This is a perfect example of the new enterprise data architecture we're seeing with customers who are using Hadoop as the ultimate staging area. So this particular customer took mainframe data, combined it with relational data, using SyncSort to connect, process, and load the data into Cloudera. They then performed a delta capture using SyncSort running on Cloudera, and finally loaded into a downstream data warehouse. So Nikhil, over to you.
What you're looking at here is the DMXH job editor. This is a single point of interface where you can develop all of your tasks and jobs in DMXH, and as you can see here, you have a master job called Teradata Mainframe CDC, or Change Data Capture. What I'm doing as part of this job is 3 separate sub-jobs. The first one is to load data from the mainframe to HDFS. The second one is to do the actual CDC, or Change Data Capture, on Hadoop in MapReduce, and the third sub-job is to load the results of those into back into Teradata in this case. It could be any other database of your choice. So let's focus on the first sub-job, which is loading the mainframe data to HDFS. As part of this this use case for a major financial institution, we were told that 85% of the data that the company possesses and wants to process on the big data platforms comes from the mainframe. So as you can tell, it's a very important use case. So if I actually double-click on the first sub-job, you can see that it has 2 separate steps. The first step is to take data from the mainframe and load it to HDFS, and this step is called the DMXH task. The second task here is to take data from the database, in this case Teradata, and load it into HDFS. The file that you're seeing here on the top left is called line item 1, and it happens to be a mainframe EBCDIC file. This file can be either local to your server that you're running DMXH on, or it could be remote on the mainframe. The DMXH has the ability to connect directly to the mainframe and pull data on the fly, convert it to ASCII formats delimited and loaded into HDFS without having to land the data anywhere in between. So let's drill into exactly what this looks like. Before I do show you the task, I want to right-click on the mainframe file and sample the data. This is an important feature. The reason it is important, if I do say sample, is because a lot of times mainframe data is very difficult to understand. And so the mainframe data usually has formats like binary and packed decimal. And what DMX-H gives you is the ability to sample the data in a very user-friendly, displayable ASCII format, as you can tell from this dialog. You can slice and dice your data on the fly while developing to make sure that everything looks good in terms of mapping the data to your COBOL copybook. So the copybook is something that you might be wondering where we got from. So the copybook is actually something that DMX-H handles very well and has extensive support for various complex data types on the mainframe. So this is the DMX-H task that is responsible for the mainframe read and load to HDFS. It has things like source and target as part of the task. It also has metadata. As part of the metadata, you have an external metadata link which has a COBOL copybook that I've imported. The COBOL copybook, in this case, is called lineitems.cpy, and it has things like packed decimal and binary data types and so on. And if I go into my demo environment, I'm using a Cloudera virtual machine where I have installed DMX-H. And if I log into there, I can show you the copybook is basically a file that I'm using to import, and it has things like comp3s, comps, which are binary data types. You can also have more complex structures like redefines and occurs depending on, which are fully supported. So if I go back to my development environment, the task has been able to detect that COBOL copybook and import it. And on the source, I have the layout from the COBOL copybook that I'm using to describe the data. If I double-click on the source, I just want to show you the variety of different sources from the mainframe. So we can pull data from the mainframe using mainframe fixed format, mainframe variable with block descriptor. So you can either have an RDW, which is a record descriptor word, or a block descriptor word. You can also have VSAM data pulled directly from the mainframe if required. And you can see this little checkbox which says treat data encoded as EBCDIC. So this is our mainframe source support. There is a lot of sophistication involved in pulling the data directly from the mainframe. On the target, you have an HDFS connection that I'm using to load data directly to HDFS, and you can see as part of the reformat tab or branch of the tree, if I double-click, it has a very simple way of mapping the data from the mainframe, which is on the left, to HDFS or Hadoop on the right. You can also see that the same job can invoke transitioning the data from a database at the same time to take data from the mainframe as well as from the database and load it into HDFS. So line items 1 and line items 2 are the two files we're loading from the mainframe and from the database, in this case, to HDFS. After I do that, it's a very simple step to take that data and invoke a MapReduce job on Hadoop using DMX-H, and that is done on my Cloudera VM, like I showed you, right on this virtual machine. And if I double-click on the second subjob, you will see that is a very simple way of defining your MapReduce job. We have native support to develop a MapReduce job. There's no requirement to do any sort of code generation or Java programming or scripting and so on. So you can see that there is a graphical mapper, set of mapper tasks, and then there is a MapReduce link, and then you have a graphical set of reducer tasks as well. So there is no requirement for you to code any MapReduce logic. There is also similarly no requirement for you to do any sort of scripting to take the data from the mainframe and land it to HDFS. And as part of this overall job, I'm taking the data from the output of the MapReduce job from the CDC, or change data capture, and loading it back to your database. So there is a very simple way to run this, which is to hit the run button. And once you hit run, you will be able to monitor the run, and you'll be able to see exactly what the results are. I'm going to show you a log from one of the runs I did earlier this week, and if I double click on one of these runs, you can see that it gives you extensive information about exactly what happened. I took 10,000 records from my mainframe file, and I took about 9,675 records from my database, in this case Teradata, and then I ran a MapReduce CDC, as you can tell from here, and then loaded the data back into Teradata, and this happens to be just the incremental data, which is 562 records. So that concludes the demonstration. As you can see, it's a very simple and seamless graphical way of defining your jobs, and there's no requirement for you to do any sort of coding or code generation in this particular use case.
So thanks a lot, Nikhil. That was great. So as Jorge mentioned, mainframes have earned the reputation for being incredibly reliable and secure. And it's the security capabilities specifically, which so many companies rely on, that often causes concerns in the relatively newer Hadoop environments. So while some companies claim to provide mainframe connectivity, they force you to install software on your mainframe that's unproven and untested, or they use proprietary security models you must then constantly sync with your enterprise security standards. That sends the alarm bells warning going with the suits. At our recent customer advisory board, with both mainframe and Hadoop customers together, we heard about several instances where proof of concepts of these other technologies were immediately shut down, despite months of planning and pre-work, when the mainframe team on the enterprise architecture board expressed concerns about data security. So Cloudera and ThinkSort offers mainframe connectivity requiring no mainframe install, and out-of-the-box support for Kerberos and LDAP. We also include user-level security that enables you to support and maintain your existing enterprise security with no compromises. It means it's loved by suits and hoodies alike. So one of the typical cost justifications of using Hadoop to optimize a data warehouse, for example, is the relative cost of storage. For example, in an enterprise data warehouse using Teradata or Oracle, 1 terabyte is typically $15,000 to $80,000, compared with, say, $250 to $2,000 on Hadoop. But mainframes tend to have even more expensive storage. As a result, using Hadoop to complement a mainframe can offer even larger cost savings. There are also some other similarities which are very interesting between mainframes and Hadoop. The most important is the perceived skill shortage in both Hadoop and mainframe environments. And it makes it really important to use technology like ThinkSort and Cloudera, which allow you to integrate these critical environments using less skilled resources. So next, I'm going to pass back over to Matt to talk about the Cloudera Manager piece.
Thanks, Steve. So just to tie those themes together, right, around closing that skills gap in Hadoop. As we talked about, Hadoop is really an open source set of projects, but you want to be able to manage it just like you do any other piece of enterprise software. So support is one component of that, but management is another. And Cloudera Manager is about providing end-to-end system management for the complete Hadoop ecosystem, not just individual projects. Customers love Cloudera Manager because it makes the complex simple. Hadoop, as you may be gathering, is more than a dozen services running across many machines with almost limitless configuration permutations. With Cloudera Manager, customers can centrally manage and monitor their clusters from a single tool, a single web UI. It provides automated installation and configuration of your cluster. And one way I've heard Cloudera Manager described is that it's really our many years of Hadoop experience realized in software, designed to help you get up and running quickly. So every mistake anybody's ever made with Hadoop, any misconfiguration, all those things are lessons learned and baked into the software itself, so you don't have to repeat those mistakes. In terms of keeping you up and running, it even provides things like rolling upgrades, so you can keep the cluster online while updating the many individual components that comprise Hadoop, because there are changes fairly frequently in the open source. Centralized monitoring tools and comprehensive dashboarding and drill downs enable rapid diagnostics of issues, plus it's connected to our expert support team so they can actually dive in and debug with you. In terms of integration, it already integrates via SNMP with other standard system management tools, and soon, Cloudera Manager will enable third-party software that runs natively on Hadoop clusters to be centrally managed and monitored within the tool. This has been another area where we've been able and excited to work with SyncSort. So to talk more about that, I'll hand it back over to you.
Thanks, Matt. So our engineering teams work closely together to integrate SyncSort DMX with Cloudera Manager. And thanks to the very flexible and open architecture of the manager, it was incredibly easy. So as Jorge mentioned earlier, the contribution we made to MapReduce to make sort pluggable means you can run our DMX engine on every Hadoop node to provide smarter ETL. But that means you may want to install DMX on every node in the cluster. Other products would require you to do this manually, but using Cloudera Manager and the parcels, you can automatically deploy and upgrade DMX on every node. And it provides that single pane of glass for command and control across your Hadoop environment, which is again great for suits and hoodies alike in an enterprise environment. So now we want to talk about a specific customer. So they'd actually already selected Cloudera and had spent several weeks trying to understand an 86-page COBOL copybook and to then move some vSAM data across. So all of their effort had been focused on manually reading through the copybook and then manually trying to map the data in. Not a pleasant experience. It's critical that people realize it's not just about writing code to do the data conversion. You also have to be able to read and validate that COBOL copybook, and that's not a task for the faint of heart. So within minutes of arrival, the SyncSort software had the copybook automatically parsed and showed them where the errors in the copybook were. About 30 minutes later, we had connected to the mainframe via FTP and had the actual mainframe data mapped to the copybook. With a total development time of under 4 hours, we were able to load vSAM and variable length data directly from the mainframe into HDFS, while the customer had actually spent weeks trying to just understand the copybook, and they hadn't even dealt with the data load into Hadoop yet. So if you're trying to bridge the gap between big iron and big data, there really is no better combination. The Hadoop market leader and SyncSort with decades of mainframe experience. You don't get to run on 50% of the world's mainframes and be the most executed third-party product without having software that is both reliable and, more importantly, trusted by the mainframe operations team. We allow you to collect and translate the data with no footprint on the mainframe and no MIPS usage by DMX. Obviously, if you're using FTP, it's going to have a degree of MIPS usage, but DMX has no footprint there. We can handle those scary COBOL copybooks and actually help you validate them against the data. We fully support the ironclad security model of the mainframe, and nobody knows more about mainframes and Hadoop than SyncSort and Cloudera. So back over to Jorge.
Thank you, Steve. Thank you, Matt, for your insights, and thanks everyone for your kind attention. I just want to mention that this presentation will be available on demand, so in case you want to revisit or share with your colleagues. And now it's time to address some of the questions that have been coming in. I guess the first one that we got is actually a fun question. When will I get my T-shirt? And the answer is you will all be getting an email within a few hours of this webinar, where you will get all the details for the T-shirts. The next question I have is, so by the way, we've got over 100 questions, so we'll try to address most of those, but for those that we cannot get here today, we'll try to get back to you offline. So I'll start with one question, and it is, so you can convert FCDIC data to ASCII using FTP. How is that different from what DMXH does? So I have Nikhil Kumar here to help me answer that question.
So that is a great question. So FTP usually just handles character data, and as you're probably aware, mainframe data is more than just character. There's a lot of complex binary types, including packed decimals and zone decimals, as well as complex COBOL structures like redefines, etc., which is something that DMX has very sophisticated support for. So it is all out of the box using the DMX native engine.
Perfect, thank you. The next question I have is, this is for you, Steve. Do you have connectivity for DB2 on ZOS?
Yeah, absolutely. So we have direct connectivity through.
Okay, and now that we are with you, I have this question. I am currently running SyncSort MFX. For those who are not familiar, MFX is our mainframe product. Do I need a specific version to talk to Hadoop?
No, you don't need a specific version at all. You can use any one of them.
And by the way, I just want to add, you don't even need SyncSort MFX on the mainframe. So as we mentioned before, you don't need any additional software on the mainframe. Another question that I have here, along the same lines, which version of Cloudera do you need to be running? So DMXH is certified starting with CDH 4.2 and above. And
if you're interested, you can actually go to the link and download a test drive.
When loading Hadoop with mainframe data, do you do it from the edge node, or how do you do it?
So we can load from the edge nodes, but also thanks to that direct integration that is directly into the core framework, we can run our engine on every single node in the cluster and load directly into the cluster. So you have the option of doing either via the edge nodes or directly into every node on the cluster.
Okay. There's a question, I think you addressed a little bit of this, Steve, but I just want to make it clear. So there's a question that says, how can you get data from the mainframe with 0 MIPS if even FTP takes MIPS?
So yeah, obviously DMX doesn't have any footprint on the mainframe. FTP obviously would have a MIPS cost, so you need to be aware of that.
Right. And by the way, if you are SyncSort MFX customer, you can use MFX or ZP copy to upload a lot of that processing that takes place before you get the data. You can upload it to the zip engines. This will be a concept familiar for all those mainframe guys. I have another question. This is probably for you Nikhil. It says the language used to retrieve the data is SQL or, I guess, something else?
So DMX does not employ any SQL to pull the data from the mainframe. The DMX native engine is what is used to pull the data directly from the mainframe and do all of the conversion from the mainframe formats to ASCII and to displayable formats and then load to HDFS.
Okay. I have actually a compliment. It says, Matt, your presentation is among the best I've heard that demystifies Cloudera to business users and translates your offerings into data function terms that make sense. So I just wanted to read that because it's very unusual to get that kind of compliments, Matt.
I appreciate that. Maybe we can phrase that in the form of a question.
So Matt, there's a question for you about SAS and BI tools on Hadoop.
Mm-hmm. Yeah, so I noticed a couple of questions come in around that. So they take the form of, hey, you said that we can run our existing tools on Hadoop, but how does that practically work? So we'll take those one at a time. So from a BI perspective, there are a number of ways to access Hadoop data through a SQL interface, through ODBC, JDBC. drivers. Until recently, there wasn't an interactive way to do that. That's what Cloudera Impala provides. It basically makes Hadoop look like an MPP database running on Hadoop. So if you're using a tool like Tableau or Qlik or MicroStrategy or Oracle or SAP or IBM Cognos, you can just connect those tools to Impala, and it will behave like a database, and you can continue to use the SQL that you know and are familiar with. SAS is a little bit different, just because they and other analytic providers have taken a more native approach to actually running directly on the cluster, just like SyncSort does. So in fact, you can actually run SAS natively on a Cloudera cluster and actually get those same benefits of pushing the compute to the data rather than replicating the data out to another environment just to run some analytics. So it really gives you some massive scalability for your analytic jobs, and that's been a huge benefit to customers so far.
Perfect. Thank you, Matt. I have another question, and this is also for Nikhil. And the question is, does it handle variable length and multi-record layouts?
Yes, DMX has extensive support for all these formats, including variable length with the RDW and the BDW on the file, as well as complex structures like redefines, which includes the multiple record layouts in the same file. And you can define all of those conditionally and convert them using one single step.
Okay, and I think this is kind of a follow-up. It's from a different person, but it's kind of related. SyncSort enables to process the backdecimal directly in Hadoop.
Yes, the way DMX handles backdecimal, it has native support for all of those data types, including comp3s, which are packdecimal, and we convert those on the fly to any format and land it into Hadoop, where you can use MapReduce to further process that data.
Okay. I have a question. I think we already answered this one, but just want to touch again on this one. What installation is required on the mainframe server? The answer is nothing. There's nothing required to install on the mainframe server. And then we have a question about specific competitors. It says, how does the SyncSort ETL use compared to tools in general to other competitors? The way I would answer this is two key things. The first one is I will probably be as aggressive as say there's no one in this space, on the data integration space, that has as much experience and expertise on the mainframe side as we do. As we mentioned before, 50% of the mainframes in the world run SyncSort. So that's already trusted, and chances are it's already on the list of approved vendors within your organization. The second part of the answer is that many of the alternative tools or different approaches, they use code generation in order to push data into Hadoop, processing into Hadoop. And we are probably one of the few tools that do not generate code, and not only makes it easier to develop MapReduce jobs with a graphical user interface, but we also allow you to harness all the performance from Hadoop by maximizing basically the throughput and performance per node. So it's kind of this combination of two things, performance plus ease of use. Okay. I have another question, and I guess I'll just rephrase the question so that it's clear. This is for you, Nikhil. The question was, do you support VSAM? But I will probably, just to clear out all the related question, I will say, what mainframe data types do you support?
Yeah, so mainframe data types are a little different from file types. So I'll start with the file types include VSAM sequential files, which could be fixed length or variable length files. And within the files, you have various data types like packed decimals and comps and binary data types. So we support all of those data types as well within those files.
Okay, so I think we have time for a few other questions. Let me look at these. Just trying to filter out the ones we already answered. I think we kind of answered most of them by now. Is there any specific question you want to address, Matt, as well? Real-world scenarios. We talk about the use cases and the case study. That was actually that's actually a real case that we had. I think that's pretty much everything.
So some of these more technical ones, we'll respond individually on. So I guess the only other thing is where to get started. So you've got to, if you're interested in mainframe data and Hadoop, it's definitely worth downloading that VM image that's linked to. And also Cloudera does great training courses, and Matt could talk about that, which we would definitely advise you to do. In fact, we've all in the room been through that Cloudera training course, so that's definitely great. Matt?
Nothing else from me.
Okay.
Thank you.
Okay. So I just spotted another question. I think we touched on this before. Can we load DB2 data to a Hadoop system? And I guess the answer is yes.
Yes, absolutely.
We covered that a little bit earlier. So that's pretty much all we have for today. We got lots of questions. So far I have 111 questions showing in my screen. Thank you for all your questions. If you like what you saw today, I will encourage you to take the next steps and try it for yourself by downloading our free test drive. It runs on Cloudera on CDH and has everything you need to get familiar with our joint solution. I would like to thank our speakers, Steve, Matt, and most importantly, thanks everyone for your kind attention. Of course, thanks a lot to Nikhil for your technical support and the demo. And have a wonderful day.
Definitely take the T-Rex T-shirt. It's much better than the elephant one. Thanks a lot, guys.